So I can, from this, I can easily find what is the overall signal power I required for getting a decent SNR. Since you know all the noise parameters are measured across a bandwidth, the usual notation is to add B along with the the signal power equation. So the previous equation itself, we are taking the total SNR across the entire bandwidth. So P signal total equal to same equation, PRS into NF into SNR output. It is multiplied by the bandwidth. So we normalize the power over the entire bandwidth. The same way, for all the noise computation, we multiply by delta F. You remember, it is the noise power bandwidth, right? Even for measuring the signal power also, we always consider over a range of frequency which is called as the bandwidth. So the above equation will clearly express the sensitivity what is required for the given SNR. See, if you fix the SNR, I can fix what is the signal power required. So if SNR is minimum, then this P signal output becomes your sensitivity. Because sensitivity is what is the minimum acceptable signal level which your receiver can decode in a very good quality. So the same equation, if you replace SNR out by SNR minimum, your P signal output will become P sensitivity. It is P sensitivity. Okay, so the same formula I'm going to use for finding out the total signal power as well as the sensitivity. And when you take logarithm on both sides, all product terms will become sum. And remember, all terms are in terms of power. So we will never use 20 log, we'll be use 10 log only. So P sensitivity, dBm equal to PRS dBm, noise figure 10 log, noise figure in dB. SNR output will become SNR minimum in dB, and bandwidth, if you consider into dB, you get 10 log B. It is the bandwidth, if you take dB, it is called as dB hertz. The unit for bandwidth in dB is dB hertz. And either you can use dB or dBm for your notation. dB means the power reference is 1 watt. dBm means the power reference is 1 milliwatt. Nothing wrong if you represent in terms of dB or dBm, the formula is going to remain the same. Okay, so sensitivity is measured by this equation.